Aesha Zuhairah and Adam Hakimie, Siti Aisyah, Amani and Syahmi, Aziz and Nurul Arinahuda. Assalamualaikum and hello everyone. In this video, we'll present a real-life problem involving grade 18.
To complete this video, we use several AI tools. First, ChatGPT to find the maths problems and help with solutions, designing the Google sites and also writing the script. Second, V to generate videos related to our problem statement. Third, MathGPT to help generate visualized solution. Fourth, Canva helps with designing the video. And lastly, Leonardo AI and Copilot to help with generating the visual. We have used ChatGPT as our main helper in finding the mathematics problem. The prompt used is give me a real-life example that related to the topic rate of change. Now, let's move on to the problem solving.
Picture this. Sand is pouring out of a hopper, forming a conical pile on the ground. The radius of this pile is increasing at a rate of 3 meters per second, and it's always half of its height. Intriguing, right? Now, let's calculate the rate of change of the volume when the radius is 2.5 meters.
Today, we'll work through an interesting application problem involving a growing cone of sand. Here's the problem. Sand is pouring out of a hopper and forming a conical pile on the ground. The radius of the pile is increasing at a rate of 3 meters per second, and it is always half of its height. Calculate the rate of change of the volume when the radius of the pile is 2.5 meters. This is a related rates problem, where we need to find how one quantity changes with respect to time based on how other quantities are changing. Let's start by defining the variables and relationships. We have V is the volume of the conical sand pile, R is the radius of the base of the cone, H is the height of the cone, and we're told about these rates. The rate of change of the radius dr over dt is 3 meters per second. We want to find the rate of change of the volume, dv over dt. Additionally, we have this relationship. The radius is always half of the height. So R equals h over 2, or h equals 2r. We also know that the volume of a cone is 1/3 pi times radius squared times height. Now, let's get a clearer understanding of what's happening physically. As sand pours from the hopper, it forms a conical pile. The pile grows both outward and upward, but in a special way. The radius is always half the height. This means as the radius increases, the height increases at twice that rate. As time passes, the volume of sand increases as well. At some point, the radius reaches 2.5 meters. At that specific moment, we want to know how fast the volume is changing. To solve this problem, we need to find the relationship between the volume and the radius. We know the volume formula is V equals 1/3 pi times radius squared times height. Since h equals 2r, we can substitute this into our volume formula. This gives us V equals 1/3 pi times r squared times 2r, which simplifies to V equals 2/3 pi times r cubed. Now we've expressed the volume purely in terms of the radius. This is helpful because we're given information about how the radius changes with time. Next, we need to find how the volume changes with respect to time. We take the derivative of both sides of the equation with respect to time. On the left, we get dv over dt. On the right, we apply the chain rule to 2/3 pi times r cubed. The derivative of r cubed is 3r squared, and we multiply by dr over dt. This gives us dv over dt equals 2/3 pi times 3, r squared times dr over dt, which simplifies to dv over dt equals 2 pi, r squared times dr over dt. Let's double check this. The derivative of r cubed is 3r squared, and when we apply the chain rule, we multiply by dr over dt combined with the coefficient 2/3 pi. We get 2 pi r squared times dr over dt. Now that we have our formula for dv over dt, we can substitute the values we know. We're given that dr over dt equals 3 meters per second, and we want to find dv over dt when r equals 2.5 meters. Let's substitute these values. dv over dt equals 2 pi times 2.5 squared times 3. That's 2 pi times 6.25 times 3, which gives us 37.5 pi meters cubed per second. If we use 3.14 as an approximation for pi, we get approximately 117.81 meters cubed per second. Let's recap the key steps we took to solve this problem. 1. We identified all the variables and their relationships. 2. We expressed the volume in terms of just the radius using the relationship h equals 2r3. We differentiated with respect to time using the chain rule 4. We substituted the known values to find the rate of change of volume. This is a great example of how calculus helps us understand dynamic situations in the real world where different quantities are changing simultaneously, but in related ways.
This concludes our video presentation for this assignment on rate of change. We hope you enjoy the explanation and learn something new. For more details and references, please visit our group's Google site. The link will be submitted together with this assignment. Thank you for watching.